Good evening, first of all, to all of you. I'm Dr. Stavros Kolios. I'm a just tutor in the Open University of Cyprus and assistant professor in the National and Kapodistrian University of Athens. I'm going to present you a study with title Forest Fire Risk Assessment in the Greek islands of Kefalonia and Ithaca using multicriterial analysis of spatial data and remotely assessed projects. First of all, the central scope of the study is to map analytically fire hazard zones and assess the fire risk within Kefalonia and Ithaca islands that are located in the western Greece, utilizing modern and reliable Sentinel-2 satellite multispectral imagery, as well as several other related geospatial datasets I'm going to present you in following. But the novelty, few words of the study concerns the combined use of different high-resolution data in order to create an updated fire risk map in areas with important biodiversity and increasing tourism activity. Also, such detailed analysis focused exclusively in the study area has never done before. Similar studies concern greater areas and were used datasets of a coarser resolution than the data used in this study. In these figures, on the right side, you can see the study domain regarding the Greek peninsula. Inside the red box, you can see the slabbing complex of Kefalonia and Ithaca in the western Greece. And on the left side of these figures, the arrows indicate the Natura protected areas of this Icelandic complex, which is a large area for the whole study domain. The datasets were used in this study as can be seen in this table. The dataset and the parameters. So, for example, regarding the digital elevation model, we extracted the sloped aspect. We used also many vector data from official data coming from the Greek Ministry of Environment. We extracted the information of the forest maps, which is of a high resolution, about 1 meter spatial resolution, regarding urban fabric, forested areas, and reforested areas. And also we used a multispectral Sentinel-2 and Korean 2018 to extract land use, land cover, and calculate vegetation index, and more specifically NDVI, in order to have a reliable classification. So some important notes regarding the data and the methods were used in the study. As I told you before, the slope and the aspect were extracted from the SRITM model with a spatial resolution of 30 meters. We used also bands 4 to 8, as well as bands 11 and 12 of Sentinel-2 for the supervised classification procedure, and to conclude the optimal detection of vegetation and forest fuels types. We used the simple additive weighting technique regarding the multicriterial analysis. We identified and 5 fire risk levels: very low, low, medium, high, and very high, that were linked with the data values in pixel basis. And also the final normalized weight coefficients for every parameter was calculated according to the principles of the selected multicriterial analysis technique, and the classified data multiplied with the relative final weight coefficients that can be seen in the table on the right. The sum of all the datasets in pixel basis define the final forest risk levels. This slide shows a general and schematic flowchart regarding the data used and the procedures were followed. All the data concentrated and image classifications were conducted. From these image classifications were extracted vegetation types, and using the vegetation types and all the initial information, we perform the multicriterial analysis in order to conclude in the final map, which is a forest fire risk assessment map for the study domain. In this figure, it can be seen analytically all the detected vegetation types and the relative fire risk level linked with each one of them. You can see in the legend on the right side on the figure. And similar maps, thematic maps, and the relations were created for all the used data. And then all these relations blended through the multicriterial analysis to construct the final map, as I told you before. Going to the results of the study, the most exposed areas to a very high fire risk are concentrated in the main mountain ridge of the Kefalonia island, as well as in the north and south parts of Ithaca Island. There are also dispersed areas of high levels of fire risk all over the examined Icelandic complex, but are very small. The largest fire risk class is the moderate one. It covers almost the 50% of the total examined study domain. The most high levels, the classes with high levels, can be seen in the right cycles above the figure. Going to the conclusions, the study is an effort to develop an analytic map of forest fire risk assessment to operate as a guide for integrating planning to decrease forest fire risk in the study area and prevent a potential destruction of the natural ecosystems along with their unique flora and fauna. This study is an attempt to combine multispectral satellite image data from the Sentinel-2 and the latest Korean dataset and detailed forest maps of high spatial resolution. And the main finding of this study is that almost 50% of the whole study domains has a medium level of forest fire risk, while 7% was identified as high. These percentages highlight the significant forest fire risk in the study area and in parallel, the necessity to organize local communities and authorities to supply them with all the necessary facilities and equipment to contribute to the degrees of the potential risk. Regarding the examined anthropogenic factors, it appears that the zones of moderate to very high hazard are located at a distance of more than 600 meters from roads and more than 3 kilometers from settlements. According to the extracted zonal statistics in relation to the natural factors, the moderate and high hazard of fire exists in areas with a predominant vegetation structure of sparse firs and trees, slopes ranging between 10 to 30%, and aspect of land surfaces of mainly north to east or northwest orientation. And finally, as a future steps of this study is to evaluate the spatial accuracy of the final product using an extensive list of previous forest fires over the whole study domain, and also to extend the study in other islands of the Ionian Sea, where the climate change and the continuously increasing tourism activity cause extensive and abrupt changes in the natural ecosystems and enhance their vulnerability. Thank you very much.